Guadalquivir River. The project was presented as an incomplete project which should be even more spectacular. The initial idea involved creating a twin brother, an identical bridge titled in the opposite direction on the other channel of the Guadalquivir River. In this initial project only one was erected because of the budget was not sufficient to cover the pair. At the Alameda Bridge there is an elevated walkway for pedestrians. In addition to the elevated walkway, the bridge features a lookout at the top of the mast, accessible by the enclosed stairway. The top of the mast is actually a lookout. Access is by a staircase inside the core of the mast. Space has been reserved for the machinery of the future external panoramical lift, and elevators and stairs have been constructed to connect the two. There is a pedestrian zone, in this case, a central area separated from the movement of the vehicles. This bridge is built on the concept of tight pylons and counterweighting. It rises 140 meters high with an inclination of 58 degrees, a divided pair of braces holding the cables, 300 meters in length, the longest in the world at the time, and create a span of 200 meters. Between the mast and the deck is a balance of forces which are transmitted by the 13 pair of suspender cables. Its working principle is that of the balance in which the equilibrium is obtained by the collapse of the mast on the horizontal. It is considered the first bridge supported by cables, in which the platform is balanced by the weight of the leaning tower. Materials. The mast is made of an hexagonal plates of steel reinforced inside by reinforced concrete. The bridge deck is designed as a metal structure and consists of a central platform and hexagonal entrance where the cables attach. In this platform, metal reeds lead some 4 meters on both sides, which rest on a slab of concrete that functions as the road. There are 2 roads of 3 lanes each. The pillars is compensate for the movement of the construction in the country. Disadvantages. One of the disadvantages of the bridge is that it wanted to be a good example of a structural art, but the bridge must also be successful at a structural engineering design. The Alameda Bridge, however, lacks the principle of efficiency and economy. So that was it. If you feel like visiting it, the Alameda Bridge is at the north end of the Cartuja Island, crossing San Jeronimo Minder to the old quarter of Seville. Although a road bridge, it has a raised
The Alameda
pedestrian
Bridge,
walk.
completed in just 31 months for the 1992 World's Fair in Sevilla, Spain, was instantly recognized as a landmark, joining the list of numerous memorable historic structures in this remarkable city.
Cable stay bridge, and it consists of a single pylon counterbalancing a 200 meters span with 13 length cables. The original intent was to build 2 symmetrical bridges on either side of the island, but in the end, the Alameda's singular design has proved most striking.
The construction of the Alamillo Bridge began in 1989 and was completed in 1992. Rather than the backstays, Calatrava allowed of the concrete steel pylon to counterbalance the deck by substituting one set of stay cables with the weight of the pylon inclined 58 degrees. He created a new type of cable stay bridge, spanning meters. 13 pairs of stay cables support an hexagonal steel box beam. The spine serves as an elevated footpath bisecting cantilevered traffic lanes 1.6 meters below. The Alamillo Bridge confounds the assumption that static objects are by nature symmetrical and inherently rigid. Lacking the traditional backstays of most asymmetrical bridges, the Alamillo Bridge incorporates potential energy into structure. The pylon's mass should tip over backward. Without backstays, the pylon should bend toward the water. Pulled by the tension cables and the road deck they are attached to. Calatrava's design achieved structural equilibrium via sleight of hand. The pylon's own weight pulls it downward. The backward can counteract the tendency of the roadway stays to bend the tower toward the water. The downward and the backward forces of the pylon necessitate a resistance only to vertical forces. This minimizes the mass of foundations and enables the pylon to gracefully stake its presence in the ground and to direct the pedestrian and automobile movement onto land and beyond.
The major benefit that the Alamillo Bridge represents is that it improves the connections between Seville and neighboring towns, making easier the cultural and economical integration, as well as reducing the journey time. This bridge also represents the soaring aspiration of the city of Seville in preparation for Expo 92, and it's a landmark, joining the list of numerous memorable historic structures in the city. This way, it becomes a tourist attraction and generates incomes to Seville.